Each year, rust and corrosion affects a wide range of industries, causing outages, downtime, and failures for sectors like transportation, utilities, and oil and gas.
If you think of industries, governments, the Department of Defense, anything like that that has metal exposed to moisture and oxygen, you're going to have a rust and corrosion issue.
Certainly there's a cost associated when a piece of equipment or a component fails due to corrosion and has to be replaced, but that's really just the tip of the iceberg. Drinking water systems, highway bridges, electrical distribution systems, even that impact is outweighed by the threat to people's safety and trust in our public systems.
When it comes to sustainability and preparedness, corrosion can lead to disaster, especially in construction, where connectors that support structures can corrode and become weak.
One most recent failure that was caused by wear was out in California. An insulator for a power line had worn over the years to the point where the hook that was holding it up broke. And when that power line dropped, it caused the biggest wildfire that they've had out there in a decade or so.
With just about any kind of structure, whether it's power poles or buildings or whatever, they're seeking to protect against corrosion and water damage by various coatings, various caps to divert water, anything to isolate the structure from the elements that cause corrosion.
In order to counteract these issues, industries across the world are implementing the use of more sustainable, engineered materials.
It's estimated that today corrosion costs the U.S. economy almost $650 billion a year. Now, those figures come from a study that was conducted back in 2002 for the Federal Highway Administration. It was estimated that we could save over half of that cost simply by implementing technology we had available at the time. So you can imagine what we could accomplish if we could take the technology developed in the last 15 years and apply it. Now, polymers represent some of the best new technology in coating science. Their unique chemical composition gives them the ability to perform exceptionally well in very adverse conditions.
Now, a highly versatile and responsive polymer coating is delivering newly available solutions for risk management and infrastructure protection.
Storm grader is inert, it doesn't react with anything, it's non-porous, algae won't plant in it, barnacles won't grow on it. If there's a Pantone code for a color that you want, we can get it in that color. It's not going to melt, it's not going to catch fire and spread like in the case of a wildfire. It's just an extremely versatile coating that has been shown to last for 50 years. We have tested it up to 128 years in accelerated life testing. Storm grader doesn't wear like a paint does. It doesn't wear much at all. It's highly abrasion resistant. The biggest hurdle that we've had to overcome is how to apply it to very large items like steel power poles, storage tanks, or even ships. The advancements in induction heating and infrared heating have made that possible, made it much more easy and economically feasible.
Solving global issues locally, Storm grader has been tested to last at least 50 years by the Electric Power Research Institute.
For at least a decade, electric utility experts have been predicting a red tsunami that is coming, and that tsunami is going to be in the form of outages and failures. Duke Energy, NYPA, and ATC approached the Electric Power Research Institute to identify a corrosion-resistant 50-year coating. In the end, we finished in the top two. We were given a thickness of 50 mils. We did it in one shot. The other guys, I think they took several applications to be able to get to the thickness that they were required to meet. They also do not have a field repair or application capability, and we do.
With the growing concern for exposed poles and pilings, the technology can be cured into different shapes, such as caps to protect wooden utility poles and pier tops.
Whether it's a wooden power pole or a fence post or a piling holding up a dock, it's still a tree. It's just dead, but it's a vascular system standing there. Moisture comes in through the top, contaminants come in through the top in that end grain, and they work their way down, and then it sits. And it'll begin to wear out. Sometimes, you're driving down the road and you're looking at these wooden power poles, and they may look fine, but what you don't see is that there is a ring of wood that has been eaten out of the top of that pole, and the only thing left is the outer shell and the heartwood in the very center. And so we started making these Duratop pole caps, and this sits over the top of the power pole. It seals all the moisture out, and it keeps the fungus and rot from beginning to take hold. We can make these with a cone shape on top to keep birds from sitting on them. It seals out the moisture, and it keeps them from rotting.
The UV and abrasion-resistant polymer coating is helping to extend the life of corrosion-prone components, even in the harshest environments.
The faster something corrodes and becomes unstable, then it becomes a safety hazard. The storm grater provides a barrier between the substrate of the structure and the environmental forces that cause that breakdown.
The message that we need to remember is that the majority of these costs and the injuries and the loss of life can be prevented. And continuing advancements in coatings technology, such as in polymers, will have a very positive impact.